Hi everyone, thank you for joining. We're going to make a start shortly. I think if in the meantime everyone should just put where they're based in the chat, that would be fantastic. It'd be great to know where everyone's located. We have someone in from Seattle, from Scottsdale, Arizona. It's amazing. Welcome. Okay, fantastic. I think we'll make a start. I think we've got a few more people in. We've got Greg from Hollywood, and we've got someone in from Portugal and Argentina. Welcome, everyone. We're going to make a start now. So welcome to today's Reactor event. So today's event is developing Windows widgets with Gen AI. And we're joined today by Peter Ball, who I'll introduce shortly. But just quickly before we go into today's event, just a quick code of conduct. If everyone doesn't mind being respectful to one another, especially in the chat, we're all here to learn. We're all here to kind of get a better understanding of the topic today. So please be respectful of one another. Please be mindful of your language. We are going to do a Q&A, but it will be at the end of the session. So we'll let Peter do his presentation, and then at the end we'll open up for questions. Any questions you have, please put them in the chat and we'll make sure to get round to them, and we'll make sure to answer them during the Q&A section. So just to introduce myself, my name is Rianne and I am the project manager at the London Reactor, and I oversee all of our Reactor events here in London. We are a Reactor. We have a number of reactors located across the globe, as you can see here. We are a technical hub for learning and training for developers, startups, and for small businesses. If you want to find out more about what we're doing and what we have coming up, please feel free to join our newsletter. You can just scan our QR code here and you will get a bit of a better understanding of everything that we do and everything that we have coming up. So now just to hand over to Peter for today's session, I'll just let him introduce himself and what he's going to be speaking about today.
Thank you very much. So welcome to developing Windows widgets with generative AI. So I'm Peter Ball, and I'm a Microsoft MVP for .NET and Windows development, and I live in Gateshead in the northeast of England here in the United Kingdom. I'm a .NET developer with over 3 decades of personal experience and over 2 decades of professional experience for web, mobile, and desktop. My web experience includes legacy.NET, ASP.NET, all the way up to modern ASP.NET with Blazor. And my mobile experience is back in Windows Phone days with legacy Windows Phone apps, all the way up to the latest and greatest with .NET MAUI. And my desktop experience is with a wide range of Microsoft platforms, starting with Windows Forms, through to Windows Presentation Foundation, Universal Windows Platform, and finally to today's Windows App SDK. I've written my own open source NuGet packages and a toolkit for Windows App SDK developers at commences.com. I also write articles and host my own podcast at rogueplanetoid.com. And I also have tutorials, talks, and workshops, including about Windows widgets at tutorialer.com. So today I'll be talking about Windows widgets and how to develop a widget provider using Windows App SDK, along with a toolkit to make it easier. I'll also cover generative AI for developers with Azure OpenAI and integrating this with .NET using Microsoft.extensions.ai. Then I'll do a demo showing off a Windows widget that takes advantage of generative AI. Then finally, I'll finish with a summary and then again, a chance to ask any questions. So let's start with talking about Windows widgets. So Windows widgets enable access to at-a-glance interactive and dynamic information, all from the click or a swipe of the widgets board in Windows 11. Adaptive cards are used with Windows widgets, and they're JSON-based UI snippets for rich interactive content. Windows widgets enable quick and easy access to at-a-glance information without needing to open an app or a website, and there's a range of built-in and third-party widgets that you can get from the Microsoft Store. You can organize and save time from the widgets board with the built-in widgets such as weather, or there's third-party widgets from the Microsoft Store, such as Messenger. Many widgets can be customized based on your own interests and preferences, or they can be personalized to show what information is important to you. Widgets can be interactive to allow engagement with content directly, or they can be dynamic, including real-time updates to text or images. Widgets are designed using adaptive cards, which can be updated partially with data binding or completely with another adaptive card. Adaptive cards are platform-agnostic UI snippets in JSON for rich interactive content and used across a range of services, which includes Microsoft Teams and Viva Connections and templates for Windows Widgets. They're used to exchange at-a-glance content using JSON-based templates, and they support elements such as text or images, and you can even lay out elements with columns or tables. Adaptive cards can be created by hand using the JSON schema, or you can use a drag-and-drop designer to add or update elements to a structure of an adaptive card, or you can even use generative AI that's freely available, such as ChatGPT or Microsoft Copilot, to create an adaptive card. Adaptive cards can be updated dynamically based on user actions directly, or they can respond to changes in data with data binding to show any up-to-date information. For more about adaptive cards, you can check out my Designing Windows Widgets with Generative AI talk from Microsoft Reactor, or you can look at any documentation, schema, designer, and more at adaptivecards.io. So let's talk about developing a widget provider for a Windows widget. Windows App SDK is used to develop modern native Windows desktop applications that can use WinUI 3, targeting all the way from Windows 10 RS5 to the latest version of Windows 11. Windows App SDK is decoupled from Windows itself and is updated every 6 months with new features and functionality delivered via NuGet. Applications can be developed using C++ with Win32 or C# with .NET, which is Microsoft's modern open source development framework. Windows App SDK is installed with the Windows application development workload in Visual Studio to create what's known as WinUI 3 in desktop applications. But if you do want to take advantage of the widget functionality, that's only available in Windows 11. That's not supported in any previous versions of Windows. But if you want to find out more about Windows App SDK using C++ with Win32 or C# with .NET, then you can visit aka.ms/WinAppSDK. So Windows App SDK applications can become a widget provider by implementing key methods from the iWidget Provider and iWidget Provider 2 interfaces in the Microsoft.Windows.Widgets.Providers namespace. iWidget Provider includes activate and deactivate widget. That's for when the widget board is interested or not in updates from a widget provider. So you can be calling any services or stop calling any services when that's no longer needed. The iWidget Provider interface also includes create widget and delete widget for when a widget has been added or removed from the widgets board, so you can set things up or dispose of them accordingly. On action invoke is when a widget action has occurred. So when a user interacts with a widget with, say, a button, you'll get an event raised for that. And there's also on widget context changed, which is when a size of a widget has been changed. So you can update the layout yourself, or you can have a dynamic layout if you want, a responsive layout. The iWidget Provider 2 interface extends the capabilities of widgets to support on customization requested for when a widget accepts customization. So that can be set any preferences or settings in your widget, and then it can return to the normal view from there. But if you want to find out more about developing a widget provider for Windows widgets, you can visit aka.ms/widget-dev-docs. Windows App SDK applications using C# and .NET can become a widget provider even more easily by leveraging widget functionality provided by my commensys.toolkit.windows app SDK NuGet package. Developers can inherit from a widget provider base class which supports the key methods from iWidget Provider and iWidget Provider 2 interfaces, along with some extra methods for add widget and update widget, which allow you to manage or register any widgets in your application, which can be one or more widgets. Developers can not only create a widget provider with this widget provider base class, but can also inherit a widget base class, which it can be used to implement a widget itself. And that can include returning the template in adaptive cards and the JSON data for a widget as well. The commences.toolkit.windows App SDK package wraps the classes that were developed by Microsoft for Windows widgets to make it easier to use, along with other useful functionality, and developers can find and install it from NuGet. You can also find commences.toolkit.windows App SDK, including a full source code and an example widget at commences.com/packages/toolkits. Okay, so let's talk about generative AI. Generative AI reduces time and effort by employing AI models to generate new ideas, automate content creation, or format information efficiently. Generative AI leverages AI models trained on extensive data sets that can encompass text, images, or other types of content, such as adaptive cards, for example. Generative AI models learn patterns and structures within data to grasp the underlying context of that data. Generative AI can even create new content based on its training data by utilizing context and patterns within that data. Output can even be fine-tuned by adjusting any prompts to produce precise, relevant results. Azure OpenAI provides developers with access to powerful language models from OpenAI, such as GPT-4o, to be integrated into their applications for content generation and more. Azure OpenAI enables the creation of innovative and state-of-the-art intelligent applications, including natural language processing and understanding capabilities. The Azure OpenAI service offers a REST API with access and integration with Azure AI Foundry, where you can do further model exploration and fine-tuning of any models using your own data. Azure OpenAI service allows developers to leverage the full power of OpenAI models, or developers can experiment with them using GitHub models. Azure OpenAI is part of Azure itself, and you can find more information about it at azure.net. And GitHub models, which can be used for free for experimentation, can be found at github.com/marketplace/models. Microsoft.extensions.ai simplifies AI integration for .NET applications by providing a unified set of abstractions for interacting with various AI services, such as language models and embeddings. Microsoft.extensions.ai eases the integration of AI services for .NET developers across various providers by standardizing API interactions to provide a simple API throughout an application. Microsoft's objective is to provide standard implementations for developers, including caching, telemetry, tool calling, and other common tasks that work with any AI service provider. Current implementations include OpenAI and Azure AI Inference for models such as GPT-4o that can be used from Azure OpenAI service or GitHub models, and is even support for Llama models with Ollama. Microsoft.extensions.ai packages are available in NuGet in preview, and library authors are encouraged to implement abstractions for other AI service providers as well. Okay, so let's take a look at a demo of a widget provider for developing a widget with Windows for Windows using generative AI. Okay, so the first thing we'll take a look at is I've got the websites open here for the various documentation. So the widget provider documentation is really, really good. So it starts with some examples that you can follow. So you can actually implement a widget provider. There's a weather widget, so you could develop your very own weather widget. And it goes through the process of creating that for you It just uses some sample data, but you could extend that with your own services. And there's also a counting widget as well. So you can basically get stuck in and develop it yourself. You can go through the example to create it in C#, or you can do it with C++ and Win32. So whether using .NET or C++, you can implement a widget provider yourself. One of the key things that you need to do when you're implementing widget provider is adjust the application manifest. I'll show that in a second, but the documentation for that is really good. So you need to make some changes to the manifest, which I'll show off. But the documentation here talks about all the different things you need to add. So a widget has some extra things that you need to provide, such as icons and screenshots that are shown when you're adding a widget to the widgets board. And all of these are documented here, and you can see each one is explained. So you can sort of define all of these, but again, I'll show those in a second. But you can define things like whether it's customizable or not. So if your widget supports customizability, you can turn that on, and all sorts of other options as well. Screenshots can also be themed as well. So if you have a light theme and a dark theme, you can have those screenshots show up as well. And the widgets themselves can obviously support the light and dark theme as well. So yeah, so plenty of things to go through there, but you can look at that documentation from the links that I provided before. Okay, so let's take a look at our widget. So just open the widgets board here, and we've got our prompt widget shown here. So what I can do is I can go to the customize options. So I've enabled customization for this widget. I could do customize widget, and we've got a couple of options here. So the first one is for something that I'll go on to after the prompt. And then the second one is a prompt. So in here, I could type in a prompt that I want to test. So what I'll do is I'll get a prompt from my notes, and I'll put that in there. So what I'm asking it to do is to describe generative AI to create Windows widgets in a Windows widget itself. Now I've got a few options for different models. So I've got the Azure OpenAI service, which is a paid option, is the first one I've got there. GitHub models is the middle option, and I've got an OpenAI provider as well. So that talks to OpenAI. So let's do the GitHub models because that's the free one. What we'll do is we'll save that, and that'll go off and generate our widget. So this is using actual AI service actually live. So the results can be a bit unpredictable. So let's see what it does. So it's produced the widget there. It's produced it with white text. So I did say it produces something that's going to be unpredictable. So let's do that using black text. And let's see if it makes that change. So what I've done is I've just amended the prompt to tell it to use black text. Let's see if it gets that. There we go. So the prompts adjusted the output. So like I said before, if you don't quite get the output you want, you can just refine it until you get it. And we can make it a bit larger to see the other options there. We've got a couple of buttons there. We'll probably go off to a website. But yeah, so that's our first one. So let's do something a little bit more colorful. So what I'll do is I'll do a different one. So I've got it because I won the MVP award last year, a few months ago. So I'm going to ask it to describe the Microsoft MVP award, and I've asked it to include some colorful text and use a rich text box. So a rich text box is one of the things you can use in an adaptive card. I'll pick the Azure OpenAI service. So this is a paid service. So every time I do this, that will use up a credit that I have. But let's do that. So what I'll do is I'll choose that option and I'll save that. There we go. So we've got our card here. So this is entirely generated in real time with AI. Yeah, that looks pretty good. So again, it's producing that using AI. What I can also do is I can provide it with some functionality. So say we want to make this a bit more interactive. So I've said in this prompt, I've said to write a paragraph about Windows widgets where the visibility of the paragraph is toggled with a button called toggle. So I'm literally telling it, create a button called toggle, but I haven't told it how to do that. I'll pick the OpenAI service this time, and we'll save that. So again, that will go off, and using the OpenAI service, we'll use the GPT-4o model to produce this widget. So here we go. So we've got a button called toggle, and it does indeed toggle the paragraph just like I asked. But the AI completely created the necessary card to do that. And I can toggle it on and off. I can customize it, and I can reset back the original widget. But as I mentioned, there's another text box there. So that text box, if you can see that, says widget data endpoint. So what I can do is I can provide it with an endpoint. So this can be any API endpoint that doesn't require any kind of API key or authentication. So what I've done is I've provided it with the cat fact one. So let's do that. I'll just use GitHub models again for free, and I'll save that. And what this will do is this will generate a widget based on that API. So whatever that API looks like, that's what it produces. It's produced the cat fact here. It's done it a bit larger, so I'll make it just large there. So it's got a cat fact there. A cat has the power to sometimes heal themselves by purring. But what I also have is a refresh button. I can click that, and that will then call the API again. So it doesn't regenerate the card. All that's doing is getting the data. So I'm using data binding to basically do that. So I can click the refresh button and it'll call the API and refresh that. I go through different cat facts as well. So we can try that with another endpoint as well. So let's do some Chuck Norris jokes. So we've got our Chuck Norris endpoint, and I'll do the OpenAI one this time. So again, I can just choose any of the providers I want, and that'll go off and request to the Chuck Norris API. And there we go. We've got a joke there. I can bring that back down again to medium, and we can just click the button, and we get the different jokes. So we can just keep refreshing. We'll get a different Chuck Norris joke every single time. So we can basically produce whatever we want. And again, that's all being generated with AI. So let's take a look at the code for that. So here's Visual Studio, and I've got my solution open here. So it's made up of 3 projects. I've got the Windows App SDK or WinUI 3 in desktop project at the top here. The second project is a library where the AI functionality is. And then we've got a unit test project with some unit tests to check the AI is working correctly. So what I'll do is I'll show off the AI stuff first. So basically, all the providers in the actual Microsoft Extensions.ai, there's an iChat client interface, and that's being used in the space prompt class, and it just basically will call that and get me the text of the prompt. So whatever prompt I provide, that's what it will return. And each of these make use of that. So we've got our Azure prompt here. So this uses the Azure way, which would be to use the chat completions client with an Azure key credential. So I'm providing it an endpoint and API key from some settings, which I'll show in a second. For the GitHub one, GitHub is exactly the same as the Azure one. So I can just inherit that just with separate configuration, just to make it easy for the demo. But that could be any compatible system. And then OpenAI itself just has an API key. So it has its own configuration. And I'm also setting the model in all of these 3 as well. But they all work in exactly the same way. I'm just using a chat client and returning it for each one. So for the actual configuration, for our Azure config, we've got our endpoint. And we've got using the OpenAI config. So we've got an API key and model. So we can share a lot of this same kind of configuration logic. We've also got some prompt configurations. So the prompts I was using, those are configured as well with a data and a card prompt. So what I can do is I can show the settings that we have. So in here, we've got our settings. So the first one is a prompt config. So I'll just read that out. So basically saying create an adaptive card using a valid schema, just so the AI produces a valid schema for a visually interesting Windows 11 widget with emoji. I'm telling it to create a single submit button with refresh. So that was the one that was calling the API endpoint. So when I was doing the cat facts or the Chuck Norris, that was why I put the refresh button in there called submit. And I told it to do that. I'm also telling it a little bit about how the data binding works, because sometimes it doesn't quite get how the data binding works. It might be a little bit random. So I've told it exactly how the data binding works, which is say to use a $ for fields and only use the fields from the API endpoints. It doesn't introduce any extra ones. So I provide the endpoint in this first value, just using a string concatenation effectively. And I also provide a sample of the data as well, as it can take so it can do the data binding correctly. And then I tell it, don't return anything that isn't JSON, because sometimes an AI will return stuff that I don't expect. So I'm just telling it not to do that. And also telling it not to introduce the markdown for JSON as well, as it'll sometimes do that as well. So just tell it not to do that. The other prompt was for the one where I was just typing in the text. It's pretty much exactly the same. But instead of the button, I just say the following contents. So whatever I typed into the box gets put in here. So I asked for it to create a widget where I could toggle the paragraph. That's where that went in. And I tell it not to include any images because it can often return random images from the internet. I don't know what those images will be, so I'm just telling it don't return any. And again, I tell it don't return any JSON text or anything that isn't JSON. So I should pretty much get something that's reasonably valid. And then the retries here is when I make any calls, I can control how many times I do this. Then I have the configuration for the 3 different types of models. So for Azure, you can basically, an Azure OpenAI service, you can create the GPT-4o model. So you go through the process there. So you can basically go into the Azure OpenAI service, spin that up, and you can create an instance there. I don't have time to go through that now, but you can basically go through that process of creating one. There is a cost to this, so you will have to pay, but the cost is very small per request. And we can set up any model we like, but the model I set up was GPT-4o, but you could create any of the OpenAI models. The GitHub one uses the GitHub models, and those are free to use. Now, there is a limitation, depending on the model you use, of how many requests you can do per day. It varies from model to model. So it could be between 50 and 100 requests per day, but that might be enough to do some testing. But if obviously you go beyond that, you can use one of the other services. But you can use other models with this one as well. It doesn't have to be OpenAI ones. It could be models from other AI service providers as well. And then we can use OpenAI directly. So we're just calling the OpenAI models directly hosted by OpenAI themselves. So we've got the choice of being able to use that. I won't show my actual API keys, of course, but you would just basically provide them here. So you just you get a key to go with any of these services, and you can provide those. So the GitHub one, for example, is a personal access token. So you can create that really easily. And then you can use those for free, like I said. Or for the Azure one, when you set it up, you'll get an API key as well. And for the OpenAI one, when you create an API key, this is where you would enter it in. So that's the basic settings for it. And then we have an enum that represents our 3 ones. So when we're choosing the different ones, I can pick through those. So how do we actually use those? So what I've done is I've got a provider here, and I inject the 3 different types of prompt from Azure, GitHub, and OpenAI, but I could have a collection of those or a set. It doesn't really matter. I have a HTTP client, so that will make the requests to the API endpoint for me. And I've got a retry policy that's just using Poly, which is another open source package where I can basically just keep trying until it either fails or works. So if it fails 3 times, then I'll get an error. We didn't get any errors this time, but if something went wrong, I'd get an error message. One of the things I check for is to see if something's valid JSON. So like I said, the AI could potentially return something that isn't valid. It pretty much does it all the time, but just in case it doesn't, I've got something here, which will check if it's valid JSON. I basically just use the JSON document.parse. So what parse will do is take the string in, and it will see if it's JSON. So a JSON structure, I'll show an example of that with the adaptive card. If that isn't like JSON, this will fail, and it'll throw an exception, which I'll catch. If it does, I know it's not valid. So simple. Or if I don't get a document at all, so for whatever reason it came through empty, I can also check for that situation as well. When I'm actually generating an adaptive card, so that's what the widget actually looks like, I use another library. Again, it's just a NuGet package for adaptive cards. And all I do is I feed in the JSON string, and it will tell me if it's valid or not. I'm using the warnings here just to select to see if there's any problems with it. So if this passes, we know it's a valid adaptive card. If it's not, it's not. So we just simply use that method to say from JSON, is it valid? Great. I also check the endpoint as well. So in case I put something incorrect in that text box where I put the cat facts link in, for example, this will just tell me it's wrong. It's using the same HTTP client as it would get the data from. It's just checking if it's a success. So nothing too complicated there. And then I get the JSON itself, which uses that same HTTP client. So I just go off, get the JSON, return that, check if it's valid. And if it is, I return it. If it's not, I just return nothing. And we just have this get method, which switches through the different types of prompt that I'm providing. So that's with GitHub, Azure, or OpenAI. And then I've got a few methods to get the JSON data and fetch the data. This one is the logic for the model. So whether I filled in one box or the other. So I've got the text box where I provide the URL. it just says if that's a valid endpoint, I put a URL in there. And then it fills the prompt in using the data prompt. So that's the setting, which had that long string. And I tell it the endpoint and the data. So I fill in those blanks. If I didn't fill in the endpoint, then the prompt's probably being used, and I basically check that. And then I use that prompt and feed it in. I feed it in with the get method. So I basically get that prompt's data. I check if it's valid. So if for whatever reason it returned an invalid card, it would show an error message, say there was something wrong with it, an extra character or something had slipped in there. It would have brought up an error message. But luckily, when I showed it off, it returned valid. But if it didn't, this would catch that. So this is the AI side. So it is really, really easy to use. You know, the prompt, this is effectively one line of code to get the actual text of the prompt, and to actually configure it is again pretty much one line of code. So with just a few lines of code, I've got the AI functionality built in, and I can just provide the prompts that I want based on the configuration. So what about the widget itself? So in this other project, we've got our prompt.widgets. It's just a normal application. And a Windows App SDK application has a manifest file. So what you can do is you can double click on this, and this would allow you to change other things about the application, like its name. But to get to the manifest stuff I mentioned earlier, we need to do the view code because it doesn't show up in the designer. So what we'll have here is our details about our application. So there's a GUID here that's generated for an application. We'll need that for the code in another section, which I'll show off. But with those values, we can basically just proceed down the way. And most of these things, if you've ever seen a Windows App SDK application, these are pretty similar. One thing I have added here is I've told it not to show up in the start menu. So because the widget is self-contained, I don't want it to show up in start because that won't make sense to a user. So I can say app list entry none, and it won't show up. And then I've got these extra sections. So these define an entry point for the application. So there's a little bit of magic going on here to tell this application that I can be a widget provider. So that uses a couple of more low-level stuff in Windows itself. So something called COM. So basically, we're a COM server, so we can receive messages from the operating system. So we're doing some low-level stuff here, but it's all thankfully abstracted away. And we just use that same GUID. So what the system will do is it'll look for a class with that GUID that we've exposed, and I'll show that in a second. And that's the point where it would actually invoke the widget's logic. And then here we've got some stuff defined. This is what I showed off in the documentation. So we've got an icon. So when you're adding a widget, there's an icon that's used. That's defined here. I can also tell it what the widget is called. So in this case, it's called prompt widget. We've got the is customizable flag turned to true. So that gives me that ability to click that on the three dots and show that customize option. If this was false, I wouldn't see that. We can then tell it what kind of widget can this be, what size. So I can, it's all three in this case, but you can have a widget that's just small, just medium, or any combination of those. And you can have a screenshot as well. And those can support theming in light mode and dark mode, like I said. But all of these things are available in the documentation and are reasonably easy to add. And you just have to fill them in accordingly. And they match a few things in the application. So with the GUID, we can go here. So basically, I mentioned a toolkit that I've written. So my toolkit basically abstracts away all the code that you'd normally have to write. So Microsoft have written loads of classes that will help. Basically, you need to implement a widget provider. All of those are contained within my package. So I'm only exposing the little piece of functionality you actually need to see. But I will show that once I've finished going through the widget. So all I need to do is inherit the widget provider base class, which I mentioned earlier. And here's that GUID again. So that GUID just needs to match the one in the manifest, and you're good to go. So this will be the point where it will invoke the widget behavior. And then for a widget itself, I've got my class here, and I inherit from widget base. And this will expose many of the other widget features I need. So widget will have a template, so what it looks like. So in this particular one, I've got a default template. So that's what it showed when I first loaded it. I can actually go there and show that. So if I just reset this one, that's the widget that you see here. So that's the same one. And this is all JSON. So if you weren't sure what JSON looked like, this is what it looks like. And this is an adaptive card. Again, I actually use generative AI to generate this. So I could put it into the application. The other template is the configuration template. So this is the text box and the prompt box. And this is then defined here. And I also have something called a choice set, which is the drop down. And I've got the 3 options here for the Azure OpenAI service, GitHub Models, and OpenAI, as well as the 3 buttons and an error text box. We didn't see any errors today, thankfully, but had anything gone wrong, we'd have seen an error show up in there. So if I go back to the prompt widget, so we've got some helpers being used to read those read those assets back in. We just have a simple card model, which just represents the data in the template. I have an update method here. So when I'm configuring it, I then call update. So I call it against this widget manager class, which again is one of the ones that I've wrapped. And you can basically update the widgets. That tells the widgets board, hey, show whatever I've got. And that's either the latest data or the latest templates. I could swap out the templates, which is what I'm doing when I change the prompt, or when I was clicking the refresh button, I'm changing the data. All of those things are handled here. We've got our constructor, which just loads in our configuration. And then we've got our on action invoked. So every time I click on a button, so there's a verb for each of those buttons. So when it's save, it does the save. So that saves the model and calls the AI functionality. If there's any errors, we didn't get any, as I said, that would show up here. We've got the reset, which just basically loads that default model. So when I click that reset button, that's what it does. And when I close, it just closes. It does update, but I have to call update as well to switch back to the original template. This last one is like a fall through, and this is actually with the refresh button. So when you click the refresh button, it goes to here, and that's basically loading the data from the endpoint. So what I did is I told it to create a button called submit, but it could be any name, but luckily it's not one of the 3. So it'll come through to here, and that will refresh the data for me, but it would just refresh the widget anyway. And then I've got the customization requested event. All I'm doing is setting the configuration to true. And then I get the data for the widget. So that's the data from the API. So when I was loading the cat facts, the actual JSON for the cat facts was coming into there, or the template for the widget, I get that way. And I can flip between the 2, whether it's configuration or not, and that swaps it around for the configuration. And then the only other key point is for a Windows App SDK application, there's the app.xaml.cs. So this is like the entry point. So if you're familiar with other platforms like your main method or in a console application or anything like that, this is the Windows App SDK equivalent. So we basically can set up our services here. So there isn't dependency injection built in directly, but we can take advantage of that functionality still by just doing it ourselves. And this is where we register the services. So I have an extensions class, which just basically loads in the configuration. So including my secrets that I didn't show, and the settings as well as classes from the library, which can also show. So I've just got some methods which inject in the configuration that I need, as well as the services. But all I have here is I create a service host for the dependency injection, but these are the key parts to actually register my widget provider. So I call this method because we're doing some column stuff. So we have to call this method just to make sure everything is initialized. I add my widget. It's got a specific definition ID, which I defined in my widget. I just new up my class, and I can pass in anything. So it can still take advantage of dependency injection, even though I'm just newing it up. I'm just passing in these services. And then I register the provider itself. And then when the application is launched, I do those things. That makes it really easy. And all of that's hidden away. You don't have to worry about it. But if you're curious, I'll give it a quick look. So I switch over to my other Visual Studio. This is the real stuff that goes on in Widget Provider base, for example. So I won't go through it, but there's a lot of methods here. And this is all the functionality that was written by Microsoft and is shared in open source. So I've integrated it into my toolkit. But all this functionality you don't have to worry about. You just have to call the relevant methods. The Widget Registration Manager, for example, we've got some things going on here. And we've got some other things that will start to look a bit more complicated. So again, it's a good reason to abstract this away. So we've got some native API calls and various other more complicated code being invoked here, but I'm able to abstract that from you. And there's also some native code as well. So we're calling some stuff into Windows itself. Again, this is the way you have to deal with the widgets. But again, that's all abstracted away. You basically don't have to worry about all this. And the widget base, if you're just curious, is all the methods that you can use inside a widget itself. But again, all of this is inside my toolkit. You don't have to worry about it. But if you follow through the examples in the documentation, you'll have to implement all these classes yourself. But if you don't want to, you could actually still follow the example and just miss those parts out and take advantage of my toolkit. But there is an example counting widget in my toolkit as well, just based on the one from the documentation. So you can see how you could make that process a lot simpler. But yeah, there we go. I'll just return to my slides. Okay, so widgets provide an easy to use and dynamic or interactive access to information at a glance with built-in or third-party widgets using adaptive cards. Adaptive cards are delivered by a widget provider for widgets created using the JSON schema, drag and drop designer, or you can even use generative AI to make them. Widget providers can be easily implemented in Windows App SDK. You can either do it on your own, or you can take advantage of my toolkit to make that a bit easier. And you can even integrate generative AI or any other functionality you like. You've got the whole .NET ecosystem to take advantage of there, so you can integrate any features, but generative AI is definitely a good one to put in there. And generally, generative AI can be easily integrated into .NET applications with Microsoft.extensions.ai implementations. Okay, if you want to know how to design adaptive cards for Windows Widget, then you can check out my previous talk, Design Windows Widgets with Generative AI. But thanks for listening to my talk about developing Windows Widgets with Generative AI. You can get the slides and code at github.com/roleplanetoid/developing Windows Widgets, or you can follow or connect with me on LinkedIn at linkedin.com/in/roleplanetoid.
Thank you, Peter. That was really, really a great session. If anyone has any questions, please pop them in the chat now so we can make sure to get them answered. We haven't had any questions come in just yet, but if you have any questions, please put them in the chat now so that we can answer them. But in the meantime, thank you so much, Peter. That session was super, super informative and really, really useful. And just like I mentioned earlier, if you want to find out more about the reactor, please see the link that I've posted in the chat. And I've also posted a link to join our newsletter in the chat as well, if you would like to find out more about what we're doing in the reactor. So we've not had any questions come in. So I think we'll end the session there. But thank you once again, Peter, for today's session. It was really informative. If you'd like to see a recap of this session, it will be posted on YouTube shortly after. But thank you, everyone, for joining.
Indeed, thank you very much.
Bye.
Thanks a lot. Bye.